So, what's the one material that shaped entire cities, built sprawling empires, and still to this day forms the very backbone of our modern world? It's concrete. And you could argue it's one of humanity's most powerful inventions, the stuff that literally turns imagination into architecture. Now, while some ancient cultures had early versions of it, it was really the Romans who perfected it. But here's the crazy part. After Rome fell, their unique formula was lost for centuries, leaving behind these structures so durable they became the stuff of legend.
I mean, just look at the Pantheon in Rome. For almost 2,000 years, its massive roof has been the largest unreinforced concrete dome on the entire planet. Think about that. Structures like this have survived earthquakes, the elements, and just the sheer passage of time, while a lot of our modern concrete buildings start to show their age after just a few decades. This incredible longevity, well, it's been one of history's great engineering mysteries.
So that leads us right to the big question we're tackling in this explainer. How in the world did the Romans create a building material so advanced that it could actually outlast our own? What was their secret? Okay, to really get the secret, first we need to appreciate just how revolutionary this stuff was. See, the Romans didn't just use concrete for a few buildings here and there, they used it to engineer their entire empire. Just think about it for a second. We're talking about these massive aqueducts that carried water for miles and miles. We're talking about huge harbors built right into the sea, an entire network of roads and bridges that connected the known world. These weren't just buildings, this was the fundamental infrastructure that allowed the Roman Empire to run, to grow, and to thrive for centuries. And the incredible part is, so much of it is still standing today. So, what was in this miracle recipe? For a long time, historians and scientists knew the basic ingredients, but it turns out knowing what was in it isn't nearly the same as knowing how they made it. The Romans called their concrete opus caementicium, and, fundamentally, it worked a lot like the concrete we use today. It had two main parts, a mortar, which is basically the glue that holds everything together, and a coarse aggregate, which is all the filler, the chunky bits of rock or rubble. So the classic recipe was pretty straightforward. Lime and water mixed with an aggregate of stone and sand. But the Romans had a secret weapon, a real game changer, something called pozzolana. This is a special kind of volcanic ash, and there was a ton of it around Naples. When you mix this stuff with lime and water, it creates what's called a hydraulic mortar, which means it can set and harden even when it's underwater. This was absolutely revolutionary, and it's how they were able to build all those incredible harbors and bridges. But even knowing about the pozzolana, something was still missing from the puzzle. The true secret, as it turns out, was hiding in plain sight, in a feature that for centuries scientists just wrote off as a simple mistake. If you look really close at samples of ancient Roman concrete, you'll notice these little bright white chunks mixed in. They're called limeclasts, and they're everywhere. For the longest time, the accepted theory was that these were just a sign of bad quality control. That the Romans were sloppy, didn't mix their mortar well enough, or that they were just using cheap, impure lime. Right, so the old theory just saw them as a flaw, a sign of poor quality. But not too long ago, a team of researchers from MIT and a few other places started to ask a totally different question. What if these little white chunks weren't a mistake at all? What if they were put there on purpose? Could these so-called flaws actually be a hidden feature, maybe even their secret weapon for durability? And that one simple question led to this incredible breakthrough that finally solved the millennia-old mystery. It turns out the Romans hadn't just made durable concrete, they had made self-healing concrete. So here's the crucial discovery. The key wasn't some missing ingredient, it was a missing process. All the evidence now points to the Romans using a special technique called hot mixing. Okay, so what is hot mixing? Well, instead of first mixing their lime with water to make a paste, which is called slaking, it looks like the Romans often added quicklime, a much more reactive form, directly into the dry mix. When you do that, it kicks off an exothermic reaction, which is just a fancy way of saying it gets really, really hot. And this hot mixing process is exactly what creates those brittle, super reactive lime clasts. They weren't a mistake. They were a deliberate result of how they made the stuff. And as the researchers put it in their 2023 paper, these little clasts basically act like tiny pockets of calcium, just sitting there, dormant inside the concrete, waiting to be activated. But activated by what? Well, the answer is damage. So to prove their theory, the team put it to the test. They whipped up some new concrete samples using that ancient Roman hot mixing recipe, making sure it had plenty of those same lime clasts. And then They did something that would probably make any structural engineer cringe. They cracked the samples right down a middle.
Next, they started running water through that crack, basically simulating what would happen over years and years of exposure to rain or groundwater. And this is where the magic happens. The water seeps into the crack and starts to react with those lime clasts.
And here is the incredible payoff. Within just a couple of weeks, the crack had completely sealed up. It healed itself. The water dissolved the lime clasts, which released a calcium-rich solution. That solution then flowed into the crack and recrystallized as calcium carbonate, effectively gluing the concrete back together from the inside out.
So the whole mechanism is just elegantly simple. A tiny crack forms from some kind of stress or weathering. Eventually, that crack reaches one of these countless lime clasts. Water gets in, activates the clast, and it releases its payload of calcium. That solution flows into the crack and hardens, sealing the damage before it has a chance to spread. It is literally a built-in autonomous repair system. Now, this discovery is way more than just a cool piece of historical detective work. It actually has some profound implications for our own future. So let's talk about how this ancient wisdom could help us build a more sustainable world.
Here's the hard reality. Our modern concrete has a massive environmental footprint. The production of Portland cement, its main ingredient, is responsible for up to 8% of all global greenhouse gas emissions. That is a staggering number for a single industry, especially when you remember that after water, concrete is the most widely used substance on Earth. But now, by finally understanding how the Romans built things to last for millennia, we actually have a potential blueprint for creating better, more durable, and more sustainable materials for ourselves. This is ancient wisdom directly inspiring modern innovation. So why does all this matter? Well, a Roman-inspired concrete could give us infrastructure that lasts for centuries, not just a few decades. That would mean a dramatic reduction in costly, carbon-intensive repairs. And by making our structures last longer, we lower the overall environmental and economic costs of construction. We could build things that are actually designed to last, and even designed to heal themselves.
It really leaves you with a pretty powerful thought, doesn't it? The Romans built structures that have endured for 2,000 years. They built an empire. We build things that often need to be replaced within our own lifetime. So maybe, just maybe, the most futuristic and sustainable building material we can imagine isn't something we have yet to invent, but one we are only just now beginning to truly understand.